as you all know, multiplication is not so popular because of its complexity, but nevertheless, you need to know at any time it will come in any format in assignment. It won't come in test because it consumes so much of time. So there's another way of doing multiplication which we learn towards the end of chapter 2. You can actually perform multiplication and so division by using the particular method, and it is much more easier compared to what we learned. So that we learned towards the end of chapter 2. So today we will continue with chapter 2. The next subtopic is actually on program loops. And this is one of the most crucial elements. Because in any program you can't actually escape from doing looping. And from loop you will learn a lot of things. So take note that this loop is very important. So the program loops here actually enables the microcontroller to perform repetitive operations. You can understand it's actually a loop. So it performs repetitive operations. So a loop may be executed a finite number of times or infinite number of times. So that means you can perform a particular loop infinite number of times, or you can also configure it in such a way that if you want to run it 5 times or a particular number of times. So what are the different types of program loop construct that we have? So we're going to see some of the four basic structure of program loop, which means all the loops will be one of these 4 formats. So let's see the first format. The first format is do as forever. What I'm trying to say is this one, you perform this task forever. That means this is an infinite loop. So we'll see the structure first, then I'll show in programming how it is constructed in MPLAB. So this one is infinite loop. What I want you to understand is the structure. What type of structures that we have. So the first structure is you do continuously, you do this loop. You remember in C, what type of do while loop, right? While true or do while. If you set the while condition to be true, it will be running infinite times. So whatever inside the content of that loop will be running infinite number of times. The second construct of loop is that this is finite number of times. That means you can actually set to run any finite number or how many times you want to load as well. So if you see this structure, this is actually the condition for loop. You remember something like this? For loop, but with condition, right? It's condition for loop. I mean, what is the condition? You are using a loop counter. What's the loop counter? Variable is I, right? I is your loop counter. So you initialize I to become 0. This is the initialization. So which means these conditional loops have, the first one it has initialization. And then what is this one? This is the condition. As long as your loop count fulfills this condition, which is if it's less than 5, that means it's true. So you keep running. So this is your condition. And what is this? This is actually the every iteration increment. So this is the iteration increment. So how does this for loop work? First, you initialize it to 0. Then you check the condition. Is I less than 5? Yes. So you perform this. When you, after you perform this one round, when you come back up, what you do? You plus 1. So I becomes 1. Again you check the condition. This initialization only done in the first part. After that, every time the incremental is actually done but each time the condition will be checked until the point where I is, like for example, I is 5. If I is 5, does it fulfill this requirement? No, because it's equal to 5, it's not less than 5. So it will go out of the for loop. You understand this concept?
Yes.
Now this is the concept that we're going to apply here. Now the I here, of course there are many ways of doing this. If you notice that there is also I minus minus, right?
Yes.
The way how you do that, this one, there's another format that you can do also. You can actually do for I equals to 5 I less 5 0 I minus minus. The same thing, you initialize the number, keep minusing, I equal to 0, go out of the loop. Okay? So there are two ways you can do. One is by initializing the loop count to 0 and then incrementing until it meets the limit. So this is your, what we can say as your loop limit, for example. So you can initialize it 0 and you keep incrementing until it reaches this one or reaches this condition, or you load the limit and then you keep incrementing until it reaches the minimum value. The two ways that you can do it. So same thing here. This is the initialization. If you are going to use incremental loop, then here you must initialize it with 0. You can either 0 or 1, depend on how many number of loops that you want. So you initialize. So this is the initialization part. So considering that I is your loop count, is the loop counter. And then what is this? What is I2? What do you think I2 is? This is the condition, that means this should be the limit. Is I less or equals to I2? If as long as fulfill the condition, this S is, what is S? S is the sequence of instruction that you want to loop for a number of times. So whatever, not necessarily one, it could be a long program. So you check the condition first. If yes, then you do this. If no, you go out. So if yes, it will perform all this, then what happens? Before you check back the condition, you will increase the loop count by 1. Do you understand the structure? Yes. Don't worry about how to implement, I just want you to understand. Is this okay? So this will be going on until the condition is no longer valid. It will go out. Is it okay?
So is it necessary to put the S there?
This S is just a representative of your instructions. Of course you must put some instruction, otherwise what you're looping. You can't be simply doing loop for nothing.
That's where
This is the whatever instruction that you want to loop certain number of times. So this one is just in a flow chart, so it's representing it just by putting S. Is it okay? Any other questions? Can follow? As I mentioned, this is from I to I2. That means from whatever initialize you done until the limit. The second one is from I2. That means from the limit down to the minimum, which is the second one. So this is the same, but this one is straight away you load the limit, high limit. Then you check whether, maybe if you want to check whether is it as bigger or equal to, you can actually check. You can either put 0 here. As long as it's bigger or equal to 1, I think you can put the condition 1 here. So that as long as it is bigger or equal to 1, it will become true. When it becomes 0, it will go out. So this is the same thing, but here you are minus it. So this is the finite loop. There are two ways of doing this. Either way you do, as long as you get this running that particular number of times, then you reach your objective. So there is no one way of doing this loop. So earlier we saw is infinite loop. I mean that runs infinite number of times. This one, depending on what you load in the loop counter, it will run that number of times. Any question after this one? Yes, no? Able to follow? Recording there. So this is the second loop construct. So what's the third one? So the third one,
Only
it actually checks the condition first.
do while. While
This is checking, it's a do while, but it checks the condition. As long as the condition is fulfilled, that means do while with a certain condition. You don't put do while true. Do while true means it becomes infinite number of loops, but do while with condition, if you put certain condition, you know, right?
yeah. Okay.
You can put condition, it will actually check the condition first. While C is true, that means you select a certain condition you put. Maybe you put a variable if I is less than, you can put a condition, you can put I less than 5. As long as I is less than 5, you continue to do the task. So this one is you checking for the condition first. If the condition is true, then you keep doing it. So at each time it will check for the condition. So this is the third structure that we have. And then the fourth one is you initialize whatever you need to actually, the loop counter that you need to check here. But then you do the task first, you check the condition at the end. So these two complement each other. This one you check condition before, you loop. This one you do the sequence first, then at the end only you check the condition. So these are the basic 4 types of loop construct. Any type of loop construct will fall in one of these 4. Is it okay? So throughout, later when we go through exercise, I will point which one is which construct, so you know how structured it is. Any question up to this point?
So
Yeah.
So you said that this one is the number 4 one repeat is execute first, then check.
Yes, it runs the instruction first, and then at the end of the program only it checks for the loop condition.
So is it the same with the for loop?
Yeah, it is almost the same. Almost the same. Actually, the for loop we check the condition on top.
just do first, then you check.
We check the condition on top. Check the condition on top. Now they are just different ways of doing it. It could have the same structure. So later, from example, actually we'll see. So when we are in the topic of looping, looping means you are actually changing the program counter. Why changing the program counter? Because the PC goes down and then you have to come up or go to another place again. Which means now the PC is not going, remember previously when you press F7 debugging, the green arrow which is actually the PC goes down and then end, finish. That means is so far that what we have done is it is one way down, goes down, and when it reaches the end it finishes. But when it comes to the subject of looping, it requires the PC to go back and do the thing again. So what is happening to the PC? You are changing the content of the program counter. So microcontroller executes instructions sequentially in normal conditions. That means previously what we done, it actually goes down sequentially. So as you all know that microcontroller has a 21-bit PC, right? Why is it 21 bits? Why the PC is 21 bits? By now you all should be seeing. Why is PC 21 bits? Yes? 2 n bits. Yes, that is because our program memory has 21-bit address. It's as simple as that, right? But why many cannot answer? Is the question difficult? It's a straightforward question, right? So that means you really still have to make sure you catch up with whatever understanding that you need. As I mentioned earlier, after these things are going to go fast, and a lot of things requires to be understood. So that requires your basic must be strong. Why 21 bits? Why 16? Why 8? That reason must be very, very strong. How to use instruction set? How do you actually define? So all that must be very strong. So PC has 21 bit, and the PC is actually divided into 3 special function registers. PC is actually divided into 3. This is PC low, PC high, and also PC upper. So each is 8 bits, 8 bits, 8 bits. Total become 24. Can't be that bad, right? 24 bits. Out of the 24 bits, we are only using 21. So, the the PCL can actually be accessed directly. However, PCH and PCU are not directly accessible. So, what do I mean actually directly accessible or not accessible? It's because when you actually use that in the looping instruction, what happens is it changes the content of PC. It actually changes the content of PC. I'll show you in a while how actually it changes. So I'm skipping this part. I want to explain the other, and I'll come back to you. So how do you actually change, or how do you actually execute the loop instructions? I mean the program loops. How do you construct? Is by using control instructions. Remember, in your instruction set, we have a lot of categories. There's one category we told that we'll see in chapter 2, and that was control-oriented instructions. So under the control-oriented instructions, these are some of the instructions that you have. So this one, the control operation, we actually skipped that part, right? So this is actually the format for the control operation. I'll explain that in a while. So we are in actually the topic of loop counter. So in order for us to actually perform the loop, it actually requires the program counter to change the content of the program counter. Then only we can actually perform the loop. But how do we actually do the loop is by using control instructions. So there are some of the instructions you learn. First one is branch. The first one is actually branch N. This branch is actually branch without condition. That means branch N means, you see the format.
Unconditional.
This is the branch instruction. This is branch, and N is how many bits?
10.
0 to 10 is 0 to 10 is 9. Bit 0 to bit 10 means how many bits you have? 11 bits. So this is, now we are actually taking this, all this are actually BC, branch, call, go to, all these instructions are control instructions. These control instructions can change the content of program counter. Do you all follow? So now we are actually focusing on the branch. This branch instruction. This branch instruction has this format. Branch instruction has this format. It takes, what is this n? N is actually literal, right? Then you have this opcode. So it has 11 bits literal. So what is this literal for? This literal actually is offset. And there is a positive offset and also negative offset. So can you find what's the range? 11 bit. Can you find if it's a sign value? What is the positive range? What is the negative range? The question is, since we have 11 bit literal here, but this literal is actually a sign literal. So what is the positive range and what is the negative range? That is my question. Yes? What happened? What happened? What's the range? Why taking so long? What's the answer? Yes? Negative 2000 until how you get that value? 2 by the power of, so 2 by the power of 10 is 1024, right? You won't get 2000. The range is actually negative 1024 until positive 1023. That's the range, right? Can I erase this one? Okay, let's say for example, this is a program memory. Let's say we have two instructions, move LW hex 20 and also add WF. There are two instructions, right? So the move WF will occupy how many locations? How many locations will you occupy? Two. Will occupy two. So, of course, I'm just starting from address 0020. Actually, this one will start from 18. After 18, this will be 1819, and then this will start at 18. But this is just for illustration purpose I'm doing this. So assume that we have the first instruction, move LW hex 20 occupying the first two, and then the subsequent one also will occupy two, right? So I'm just writing like this. I don't think it's thought like this. It's not thought like this. Then we have the branch. This branch instruction format, can you see in your instruction set? What do you have after branch? Branch and write. Branch and write. The and is actually the offset. So branch and. So let's say now, I want to repeat these two instructions. So where should my PC go back? It should go back to the first line, right? That's how the PC should go. So look at this. Initially, the PC will point here, right? And then when you press F7, where will it point? It will point here, right? This one will be executed, this one will be fetched. Then you press F7, this one will be executed, it actually will point here. Then you press F7 again. When you want to execute this instruction, the PC is already pointing to the next instruction. So that means, when you want to execute this branch N, your PC is already pointing to the next address. But then you want the PC to go back here. So from here to here, how much is the offset? 6. So if you see is 1, 2, 3, 4, 5, 6. It is actually 6. But take note that the PC only moves in step of 2. 3. The PC can only move in a step of 2. PC can only move like that, and PC can only move in step of 2. So the actual offset is 3. It is 1, 2, 3. Now the thing is it the offset, is it positive 3 or negative 3? It's negative because you're going up back, right? So it's actually this N offset is negative 3. So what I should write there is branch, I should write the N is, should I branch negative 3. So what does this branch instruction do? This branch instruction will use this offset and change the content of PC. It will change the content of PC. So let's go back to the earlier slide. It says that only PCR can be accessed directly, however PCH and PCU are not directly accessible. So how can you access the PCH and PCU is by accessing the PC latch H and PC latch U. So reading the PCR will cause the value of PCH and PCU to be copied to PC latch and also PC latch upper. Writing will cause the values of PC latch high and PC latch U to be returned to PCH and also PCU. So in normal program execution, the PC value is incremented either 2 or 4. to implement a program loop, the processor need to change the PC value by a value other than 2 or 4. That means how much in there. So let's say now we're going to execute this one, branch -3. So what happens is, when you are executing that branch -3, what is the content of your PC? Your PC is already pointing to 0026, right? You understand why it's pointing to the next one? Because PC, if you see the definition, it points to the next instruction to be executed. So while you're executing, when you want to execute branch N, your PC is already pointing to the next location, which is 0026. So what is the content of PC? It's actually 000026. This is the current content of PC. Do you all follow? Now when you execute that branch, what happens is, the CPU reads the content of the PC. When it reads, because PCL can be directly accessible, you can actually directly access. I mean, you can straight away add to PCL. So that's why I'm actually putting here PCL. But these two, they are not directly accessible. That means you cannot change the content. That means you cannot do operation on PCH or PCU. So what it does, it copies the content into PC latch high and PC latch U. So whatever here is copied here, whatever here is copied here, so we have X00. This is from PCL. I'm using serial PCL here. X26. Why is this happening like this? This is while all this is while branch is executed. This is what happens when the branch is being executed. Now what does the branch do? What is the offset? -3, right? It is actually plus -3. So what is the new address? You get hex. This is same. This one also same. This one become of course this one offset you must multiply by 2. So it's actually -6. So you get back to 0. So where is this? This is inside PC latch I. This is PC latch U. PCL you can directly perform. So or we can actually say -6. Take the step. Each one of the step. So which means, but take note that in each step is actually two locations. So here actually the step is 3 multiplied by 2 is 6. So it's -6. Whether there we write actually -3, which is 3 steps. This 3 is actually the 3 steps. Each step is equivalent to 2. So -6 you get back this one. So this is the content of PC latch U, PC latch high and also PCL. You see that you can actually directly minus from PCL. So after you have gotten the answer, what will happen is it will write back to the PC. So from PC latch upper content, which is this one, it will write back to here. This one will write back here, no change here. But this one is already changed, right? Becomes, because of this, when this branch instruction changes the content of the PC, and therefore the PC will again from here it will point back here. You follow?
Yes.
Now this offset can either be positive. Positive means you can go further down. or negative. That's why I say that the n is actually a sign number. The offset is actually a sign number. So what it means by 1024, negative 1024 and positive 1023, it means that it can go 1024 steps up and 1023 steps down. That is the range. That means branch has the limitation. That's the range that it can go up. That means it can go 1024, negative is 1024 up, 1024 down. So that is the range. So it's quite a big range actually for branch. Is it okay? So let's say in MPLAB whether it really is it happening or not. But now the thing is, sometimes the problem with the offset is you have to keep counting, right? How many steps? Oh, this one, okay. Now the program is very short, relatively very short. So yes, you can put the offset very easily. But then the program is you can't be counting. Okay, 1, 2, 3, 4, 5, 6, 7. Okay, then put this offset. Oh, now going up, down, they count. So that is not a very feasible thing to do. So the best thing that we can do is by using label. So let's say instead of putting the offset here, if we put the label, the offset will be automatically calculated by compiler. As easy as that. So let's say we want to go back to the first starting part here, right? So what do you think the label I should put here? What do you think the label I should put here? I put like start now. Because this first line has a label start, right? So I can actually branch to start. See, go back to start. Go back to start. So this is an infinite number of loops. No matter what, it keeps running. So you can view.
We are not giving any condition, so you can.
So this is the start. Like here you see we put branch start. So the branch start has this opcode. Within this opcode there's also this. There's also this offset. But it doesn't show also -3. Does it show -3 offset here? How do you know it's -3? What is FD? What is D? It's actually no space. Can I this part? How much is D? 13, right? This is a negative number, right? What's the value of this negative number? What's the formula I told you? Take the value of 0 plus 1, right? What is the value of 0? 2. Twice. 2 plus 1?
3.
That's -3. Fine. FD. Of course, if you see the instruction set, you can know what's the full of code. But if you take this one, this is actually the offset, right? You get -3. So it is offset by -3. So optionally, you can put branch -3 here also. It will go back there. But you have to put -3, yeah? You have to put -3. Then it will automatically convert into FD. Okay? Any questions at this point? So far that what we have learned is, we have learned the program loop structure. And this program loop structure have 4 types of loop construct. And when we're talking about the loop, definitely there is how do we actually change, whenever we talk about the program loop means it is changing the content of PC. Then only you can actually move up and down. So how do we actually change the content of PC is by using control instruction. So the first instruction that we came across is branch. So when we use branch, what is the effect that happens to the PC that we just saw? How does the content PC actually change is, it will actually extract the content of PCH and PCU into PC latch high and PC latch upper, but PCL can directly be accessed. So whatever the offset that you put, it will be added to the PC content and therefore changing the content of PC. So when you change the content of PC, definitely the PC will actually change its location, and therefore the first example that we see is the first instruction we use is actually branch. That's the first control instruction that we actually done. So play around with this instruction. Ya, kajian, ini kajian. Muhammad Daniel.